Hi to all. Today we are going to discuss about output equation of transformer. Before going to output equation of transformer, what is transformer and types of transformer you have to see. Transformer is a static device which will step up the voltage or step down the voltage without changing the frequency. That is called transformer. Okay, now see types of transformers. There are various types of transformers used in the electrical power system for different purposes like generation, distribution and transmission and utilization of electrical power. Okay, the different types of transformers are step up and step down transformers, power transformers, distribution transformers, instrumentation transformers, and so on, potential transformer like this. And mainly it can be classified into two types: single phase transformer and three phase transformer. Okay, now we will see the output equation of single phase transformer. Before going to single phase transformer output equation, we have to know some of the details or things. Okay, pi m. Pi m is the main flux or maximum flux which will be generated when we give supply to the primary winding of transformer. It will be its unit is Webers. Like Bm is the maximum flux density, that is Webers per meter square. Ai, A suffix I. Here I is nothing but iron. Okay, so net core area with in meters square, net core area iron. Normally in transformers we are using two things. One is iron as a core and copper as the winding. Okay, now AI is a net core area. It is in meter square, and AC area of copper in the window, it is in meter square. Okay, AW is the window area. Normally the cores will be in the shape of windows. Okay, and del is the current density, it is ampere per meter square. A small gi, gross core area, it is in meter square. And d is the distance between core centers. Normally the core limbs will be there, no, there we are rounding the windings. So one limb to another limb is called distance between core centers. Okay, a small d is the dia of circumferencing circle, it is in meters. And kW is the window space factor. And frequency f, we know it is in hertz. Okay, ei is the EMF per turn, its unit is voltage. And TP, TS, TP, the P indicates primary and S indicates secondary. So number of turns in primary and number of turns in secondary, TP and TS. And IP and IS, I told no, P and S mentions the primary and secondary. I we know current, so current in primary and current in secondary. Same way Vp and Vs, voltage in primary and voltage in secondary. So next one AP, A is nothing but area. Okay, so area of conductor of primary and secondary winding respective, its unit is meter square. Okay, Li, mean length of flux path in iron. Okay, and LMT, LMT is nothing but length of main turn of transformer windings. It is in meters. GI, GI is nothing but weight of active iron. It is in kg. GC, the C indicates copper. No, I told no. So GC, weight of copper in kg. And small GI, weight per meter cube of iron. Okay, now come to Gc, a small Gc is a weight per meter cube of copper, that also in kg. Okay, and Pi, we know power loss, so loss in iron per kg in watts. Similarly for Pc, Pc is nothing but copper loss, loss in copper per kg, it is also in watts. Okay, now come to single phase. Okay, these are the terms everyone should know before going for single phase transformer output equation as well as three phase transformer output equations. The terms GC, PI, PC and LI, AP, AS, VP, VS, IP, IS, TP, TS, like this. Okay, now we are going for single phase transformer. The voltage induced in a transformer winding with T turns and excited by source having a frequency F hertz is given by voltage per turn. So Et is equal to capital E by T, that is equal to 4.44 F into pi m. We know E is equal to 4.44 F pi m into N. N is nothing but number of turns. If it is N1 for primary, if it is N2 for secondary. Okay. Okay. Now the window in a single phase transformer contains one primary and one secondary winding. Okay. What it means normally in the previous semesters what we studied, in the single side one side will be the primary and another side will be the secondary winding will be present. We saw the diagrams like that only, but actually it won't be like that. Okay, the each limb we have primary as well as secondary windings in both the limbs. Why? Because to reduce the leakage flux. Okay, if you connect one limb primary and another limb in secondary, that time that flux path should take from this side to that side. That time what will happen, the flux leakage may occur. To avoid this one, normally or in practically the transformers windings in both the sides, both the limbs primary as well as secondary will be present in both the limbs. Okay, that's why here we are writing, okay, the window in a single phase transformer contains one primary and one secondary winding. So total copper area in window, AC copper area, okay, of a primary winding plus copper area of secondary winding. So we can write primary turns multiply with area of primary conductors plus secondary turns multiply with area of secondary conductors. So AC is equal to TP AP plus TS AS. We can write copper area is equal to TP AP. TP is nothing but primary turns and AP is nothing but area of primary. Similarly, TS AS. TS is nothing but secondary turns and area of conductor in secondary turns AS. Okay, taking the current density del to be the same in both primary and secondary windings. I told no, we are winding both primary as well as secondary in both the limbs. Because of that, we are taking del to be the same in both primary as well as secondary windings. So we can write AP primary conductor area, AP is equal to IP by del as well as AS is equal to IS by del. So the total conductor area in window AC is equal to TP IP by del plus TS IS by del. So here del is common, so we can take TP IP plus TS IS by del. Okay, here TP IP is equal to TS IS, that we can write as AT. So if you write like this, we can get the equation, the above equation 2 AT. Here AT plus AT by del. So 280 by del. The equation 2 we are getting like this. Okay, the ratio of copper area in window to area of window. Kw is the window factor. So conductor area in window, that is AC, conductor area or copper area, divided by total area of window area AW. So Kw is equal to AC by AW. Okay, so conductor area in window, AC is equal to Kw AW. Okay, so from equation 2 and 3, 280 by del is equal to Kw AW, or AT is equal to Kw AW del by 2. So these are things we'll when we go for solving the problems. In some problems they will give the value of AT like that. Okay, there we can find the value like this. Okay, rating of a single phase transformer in kVA. Normally transformers rated in kVA, Q is equal to VI. Okay, here instead of VI, VP, IP. Okay, primary voltage and primary current into 10 to the power of -3 is a rating of the single phase transformer in kVA. So instead of VP, we can write EP, because VP is nothing but primary voltage, EP is nothing but induced voltage in primary. The both the voltages are more or less equal. So VP is almost equal to EP. So we can write EP IP into 10 to the power of -3. Instead of EP, we can write ET into TP. Okay, from the previous equation, okay, we can write ET into TP into IP into 10 to the power of -3. Okay, so TP IP is nothing but AT, we know. So ET into AT into 10 to the power of -3. So we can replace the AT. AT is equal to Kw AW del by 2. That one we have to substitute here. We will get ET into Kw AW del by 2 into 10 to the power of -3. So ET is nothing but previously we found no here. Okay, it's not going. Okay, so from this we came to know ET is a 4.44 F pi m. Okay, so we can substitute the values of ET and AT. 4.44 F pi m multiplied with Kw AW del by 2 into 10 to the power of -3. If you simplify this one, we will get 2.22 F pi m Kw AW del into 10 to the power of -3. Okay, but pi m is the maximum flux density and net core area. So we can write Q is equal to 2.22 F Bm del. So we can write Q is equal to 2.22 F Bm del Kw AW AI into 10 to the power of -3. Okay, here F is the frequency, Bm is the maximum flux density, del is the current density, Kw is the window factor, AW is the window area, and AI is the iron area, multiplied with 10 to the power of -3. It in unit will be kVA. Thank you.